Okay, we have the second problem. Well, not second, but it was the second problem on the spring of 2002, basically a couple of semesters ago. Okay, and we have parameters of the transistor, resistors, right? 60, 20, and R4 equal to 1 kilo ohm. Okay, have those resistors, and we are basically asked to find the collector voltages, the base voltages, the current on the bases, and the currents on the collector. That's our mission. Okay, how do we start? Okay, so our first step, just like we have done in previous problems, find the Thevenin equivalent to this resistor divider, right? Have a voltage and a resistor. I connect it to ground. The voltage is VB and resistor RVB. Okay, so in that case, we find the Thevenin equivalent circuit. The voltage on the Thevenin equivalent is 10 volts from the top divided by the sum of the resistors multiplied by the resistor R2 that equals to this voltage, right? Of course, we disconnected the load to do this computation. Then find the equivalent resistance looking this way, 20 parallel with 60, which is just 15 kilos. Now we can work our loop, right? Basically this loop that continues here, right, with these two voltages. So you can see that this loop containing the base emitter voltage is the Thevenin equivalent has to be equal to 0.7, right? 0.7 volts from emitter to base, plus the current across the RV, right? It's IB times RV, plus the emitter current times R4. Okay, I swap the order of this one, right? Maybe we can actually have them backwards. So now IB, we factor all the constant terms on one side, the 2.5 for VB, the 0.7, and then we just do the coefficients for IB, knowing that this one is beta plus 1 times IB, right? Just plug in there, find 20.93 kilo ohms, okay? Current on the collector, beta times the current on the base, 1.465. Voltage on the base is the voltage on the meter plus 0.7. Okay, let's actually do that. The voltage on the base, like this voltage V1, is equal to the voltage on the meter plus 0.7, right? Because there is 0.7 from base to emitter. Okay, we have it right there. So now the voltage on the meter is what? Is the current on the meter that we already found times R4. So we have it right there. So it basically is beta plus 1 times the current on the base. And it came from here, right? So we have it right there. Plus 0.7. Okay. Now the last step, find the voltage on the collector. We're almost done with the problem, right? There's 10 volts from the top, right? 10 volt right here, minus 0.7. That goes to the voltage on the collector, 9.3. And I believe that pretty much ends the problem. Let's see. Okay, current on the collector. Basically, is the current on the collector 1. Let's actually put it here. Current on this collector has to be the same of the current collector 1 plus the current on the base. Sorry, current on the collector 2, right? IC2 plus IB2 must be equal to IC1. So IC2 plus IB2 is equal to IC1. And we know that this one here is beta IB2, right? So we can just factor IB2 and we find our base current 20 microamps, right, or 0.0263 milliamps. With that, we find the voltages in the collector 1, voltages in the collector 2, right, because they are equal. The currents on the collector 1, the current on the collector 2, I guess we have just one more step. This is going to be when we take this current, right, so we have collector 2 is beta times IB2, and that pretty much ends the problem. Okay, so we have right there beta IB2 1.44, and we're pretty much done with the problem.